Imagine it's the year 1905. One morning in Bern, Switzerland, the clock on a tower is running 2 minutes late. A man who lives nearby relies on this clock to wake up for work. Because of the delay, he wakes up later than usual. Realizing he's behind schedule, he rushes to get ready, drinks his coffee quickly, and leaves home 5 minutes later than normal. As he crosses the street, a banker gets into his car, unaware that the brakes are faulty. The man steps onto the road without noticing the car approaching. Tragically, he is hit and killed. That man was Albert Einstein. That same year, Einstein was supposed to publish 4 groundbreaking papers that would lay the foundation for modern physics. Without them, key innovations, such as GPS, TV screens, and the semiconductors that power our laptops, never come into existence. The devices we use every day, including the one you're watching this video on, are never invented. And this video itself, it wouldn't exist. This chain of events illustrates the butterfly effect, a concept from chaos theory. For centuries, scientists believed the world operated like a precise machine, governed by Isaac Newton's classical physics. If you knew an object's current state, you could accurately predict its future. But chaos theory challenges this idea, suggesting that not everything follows a predictable pattern. As early as the 1800s, mathematicians suspected that not all phenomena could be explained by Newtonian physics. However, it was meteorologist Edward Lorenz who made chaos theory visible. In 1961, Lorenz was working on a computer model to predict the weather. He entered data such as temperature, humidity, pressure, and wind direction. The computer generated a graph that closely resembled real weather patterns. One day, he wanted to double-check a result. To save time, he manually re-entered some numbers and stepped away for coffee. When he returned, the graph was completely different from his original. Initially, it followed the same path, but then it veered off in a drastically different direction. What had gone wrong? After reviewing his input, he found the discrepancy. He had entered a number that was off by just 3 decimal places. A tiny difference, like removing a single feather from a duck or a speck of dust from the Eiffel Tower. This small variation had created massive changes over time. Lorenz realized this wasn't a one-time error. It was proof that in certain systems, tiny differences lead to enormous consequences. This discovery led to the famous idea that the flap of a butterfly's wings in Brazil could set off a chain reaction that results in a tornado in Texas. Despite our understanding of the universe, we can't measure the exact position and speed of every atom. These small uncertainties make long-term predictions impossible. This is why weather forecasts, for example, become less reliable the further they extend into the future. However, chaos does not mean randomness. The universe still follows cause and effect relationships. Even in chaotic systems, patterns emerge. In fact, when Lorenz mapped his weather model, it created a butterfly-shaped trajectory, reinforcing his discovery. The butterfly effect has real-world applications. In the stock market, small fluctuations can trigger financial crises, making precise predictions impossible. In medicine, it helps us understand the chaotic patterns of cardiac arrhythmia. Even in social dynamics, a single negative comment can ignite an entire wave of online trolling. But despite the unpredictability, some things remain constant. The sun will rise tomorrow. Planes will keep flying. Cause and effect still govern the universe. What chaos theory ultimately teaches us is the limit of our knowledge. It reminds us that even in a world of patterns and laws, uncertainty is always part of the equation. Thanks for watching this video. If you liked it and want to continue learning more about topics like this, subscribe to the channel and activate the bell so you don't miss the next videos.